Good evening, everyone. Hello, and everyone is fine now. I was just trying to see your response option there, response chat group there. So now everything is fixed now. I will start the class there. So I was just trying to solve that issue there, and I hope that many of you are there in the classroom there. Okay. So we will start the class now, right? Okay. Last class I have discussed about orbit. I have gone through the handout and I mentioned about the orbit and this part of it, right? We will be today going through the concept of orbit again. Along with the concept of orbit, we will also discuss about launch vehicles. And in that context, we will be going to see PSLV, GSLV and development of launch vehicle technology in India. At the same time, we will also see about the satellite part of it. So let us first start with the topic of this orbit. If you recall that last class I was going through the handout there and I mentioned that the orbit can be circular or elliptical, right? When an orbit is elliptical, you have a nearest point to the earth called as perigee and the farthest away point from the earth called as the apogee, right? Now plane of the equator, this is called plane of the equator, right? This is the plane of the equator passing to the center of the earth, and the orbit plane of the orbit can be inclined to the equator. You can see that there can be an angle of inclination, right? And I have gone through this concept of perigee, apogee, inclination. We have also covered about types of orbit, like here polar orbit, which is also called north to south orbit, or it is also called morning to evening orbit because it follows the direction of the sun, what is called as the sun synchronous polar orbit. We have also discussed about geostationary satellite for communication, and they are placed into geostationary orbit, which is a circular orbit lying on the plane of equator, and it is 36,000 kilometers, approximately 36,000 kilometers away from the earth's surface. And in that context, the time taken by the satellite to complete one revolution around the earth, right, one round around the earth is same as total time taken by the earth to have one rotation time period, that is 24 hours. Earth takes 24 hours for one rotation. The satellite also complete one revolution in 24 hours, and the direction of the revolution of the satellite around the earth is same as that of the earth's rotation direction, that is a west to east. So it is used for communication purpose because when we place the satellite into such orbit, the satellite seem to be fixed from ground station. That is what is called geostationary. It seems to be stationary, but actually it is not stationary. It also goes around the earth, right, on its orbit, but from a point on the earth it becomes relatively fixed, right? That is called a geostationary orbit, and where we place geostationary satellite or communication satellite. Then we have also seen this polar orbit. I have mentioned that north to south. So if you see here this diagram, this is the polar orbit, north to south. This is the north to south polar orbit, whereas this one on equatorial plane, almost around 36,000 kilometers from the earth's surface, you have the geostationary orbit, right, which I have mentioned that it takes, satellite takes 24 hours, right? Is it clear here, right? Is it clear? So this part we have already covered there, and I mentioned about the sun synchronous polar orbit and all, and the satellite today, right, satellite communication and all is a very, very important area of communication and used for various part of it. So what I will do here is that we will go through the concept of orbit again. Let me now come to the on the whiteboard, whiteboard here. So here what is an orbit? Orbit is an imaginary path, right? It is defined as an imaginary path taken by either a celestial body or a heavenly body, like let's say moon or the planet, or planet going around the sun, right, in the solar system, or can be a man-made artificial satellite or a spacecraft. Imaginary path taken by a celestial body or man-made artificial satellite. Right? Now the orbit can be classified, right? Types of orbit we can take. So I'll put everything in the flow chart here. The first type of classification of an orbit, that is in terms of shape of the orbit. Right? So the two are there, elliptical orbit right, or circular orbit. Right? In the elliptical orbit, I have already mentioned that if this is the Earth, then in this context there is the part of perihelion, where perigee, like same as what Sun has got perihelion for the planets. Here you have a perigee, and then you have apogee. Right? Now in circular orbit, it will be a circular one. Right? It becomes a circular kind of a orbit there. Right? So right, circular orbit there. So this one part. Now second classification what comes, that is in terms of revolution, that is a movement of the satellite on its orbit. Now based on the movement of satellite in its orbit, right, we can have first one, that is called as a geosynchronous orbit. Right, geosynchronous orbit. Now what is geosynchronous orbit? Geosynchronous orbit is that orbit where on this plane, like here, it is a satellite can go around the Earth. Not necessarily it may take the same time period. Can we have perigee and apogee? The satellite can move on its axis in such a way, on its orbit in such a way that it is based on the rotation of the Earth. Right? Here, as the satellite goes around the Earth, the Earth rotates on its axis. Right? So here the movement, or you can say the revolution of the satellite, is synchronized with respect to rotation of the Earth. Right? What is the main thing? The satellite which goes around the Earth, it moves in such a way that it has been synchronized to move with respect to Earth's rotation. That is called geosynchronous. Whereas the another one, what is called sun synchronous. Sun synchronous orbit. Now what is sun synchronous orbit? Sun synchronous orbit is such an orbit where a satellite goes around the Earth from north to south. It follows the north to south direction in a polar orbit. Right? It follows a north to south direction in a polar orbit, and it is synchronized to go with respect to sun's direction. It is based on the radiation of the sun which fall on a particular path, particular place on the Earth. It tracks, it follows that one. Right? So here the movement of satellite in its axis is synchronized with respect to sun's direction, that is where the Earth, Earth rotates on its axis, but at the same time Earth also revolve around the sun, right? So it is based on the Earth's revolutionary aspect. So based on with respect to revolution of the Earth around the sun. I'll again repeat there what I have given here. Let me repeat again. Sun synchronous orbit is that orbit where the satellite goes from north to south in a polar orbit, and it is also called morning to evening orbit. What is morning to evening? It follows the sun's position on that particular area where the sunlight falls from the morning to daytime. The satellite tracks that one. Now it is based on Earth's revolution around the sun. So if you take the Earth takes 360 degree, let's say Earth completes one revolution in a 360 degree angle, right? If you consider 360 degree there, and let's say approximately 365 days, but you know that total number of days in 1 year comprises of 365 1/4 days. But let's consider 366 days. Then it means that it must take here the angle of the orbit must almost go by 0.8 degree per day. That means this angle, the satellite orbital plane, it makes an angle with the sun, and that changes, that rotates. I am talking about the plane of the orbit. This is the plane of the orbit. The satellite which goes from north to south in polar orbit is the plane of the orbit, and that keeps on moving, right, rotating as the Earth revolves around the sun. So almost 0.8 degree per day there is a tilt of the polar orbital plane with respect to the Earth as the Earth revolves around the sun. This is what called sun synchronous polar orbit, SSPO. It is called a sun synchronous polar orbit. Now let's look at here. I will just show you through an animation part. You will be able to learn better way what basically sun synchronous polar orbit is all about there. See, whenever you have any doubt in terms of understanding any kind of a concept in science and technology, it's always better to refer to some kind of animation or some kind of a video which basically details in terms of how it goes into that, right. Now if you see here, this is the first preview I will show you in terms of the orbit here. What you see in the red color, right? What you see in the red color it basically the orbit which is a polar orbit, red in color, and that rotates, that plane of the orbit rotates with respect to sun. That is called sun synchronous. Right, that is called as a sun synchronous orbit here. Now furthermore you can understand here, I will take you to the
a polar orbit has an inclination, so these angles are still equal and the same. Gives the time derivative of the right ascension of an orbit with respect to the p, which is the orbit parameter, which is a function of the semi-major axis and eccentricity, and I, which is the orbital inclination. So this equation right here describes.
Hello friends, welcome to
Hi viewers, this video is in response to a question asked by our viewer named Jia Gupta. The question was, what is the difference between geosynchronous and geostationary satellites and their applications? Before we go further, let us first understand what is geosynchronous and geostationary orbits. The word geosynchronous means something which is synchronized with Earth. So a satellite in geosynchronous orbit would make one complete rotation of Earth in exactly the same time as Earth completes one rotation around itself. That is 23 hours, 56 minutes and 4 seconds. A special case of geosynchronous orbit is geostationary orbit. This is a circular orbit at 35,786 km above Earth's equator. Like a geosynchronous orbit, a satellite in geostationary orbit would also complete one rotation around the Earth in one day, that is 23 hours 56 minutes and 4 seconds. But the main difference is it also moves exactly at the same speed and direction as Earth. Just as two cars moving in same speed and direction appear to be stationary to each other, the satellite in geostationary orbit will also appear stationary to Earth, thus the name geostationary. To understand this difference better, let us take the following example. For a person standing on ground and watching the sky, a geosynchronous satellite would be at same position in sky, say point A, at exactly the same time of the day every day, say 12 pm. Thus at 12 pm of each day, the geosynchronous satellite would be at point A. For the same person watching a geostationary satellite, it would appear at same position, say point B, throughout the day, that is stationary to him. Thus any time of the day he looks at the sky, this geostationary satellite would always appear at point B. From the above difference, we can see that a satellite in geostationary orbit would be very easy to track from ground. That is, the antennas of the ground station can point to the same position in sky, that is point B in the previous example we saw, and need not change its position except for few minor adjustments. This makes the system much simpler. This is the reason why geostationary orbits are preferred orbits. The only reason a non-geostationary geosynchronous orbit is used is as follows. A geostationary orbit cannot provide good coverage in high altitude areas, that is polar regions beyond Arctic and Antarctic circles. This is because as latitude of a location moves up north from equator, the ground station antennas will need to be positioned more and more towards a point towards horizon. At equator, a geostationary satellite is vertically above it, but at polar regions, the satellite appears to be at horizon. Thus, for a ground station in polar region, the signal would have to pass through large portion of land and could be blocked by land topologies, mountains and even buildings. To avoid this, the Soviet Russia devised a practical solution. They devised a special elliptical geosynchronous orbit which provides better coverage in specific polar regions. Tundra orbit is an example that has been used since the time of Soviet Russia. It is a highly elliptical geosynchronous orbit with high inclination of 63.4 degrees, similar to what is shown here. By using this orbit, the satellite would remain above Russia for most of the day for satellites used by them. But eventually, the satellite would move away and will be away for a brief period of time. To provide continuous coverage, a constellation of 2 to 3 satellites would orbit in same tundra orbit, and at least one satellite will be covering the area at an instant of time. As far as application goes, both geosynchronous and geostationary satellites are mainly used for communication, broadcasting, positioning such as GPS, and for monitoring weather conditions. Alright viewers, what do you all think about this answer? Do let me know in the comments. And if you have any other questions regarding aerospace, do ask them in the comments below. And as always, do subscribe to our channel for more aerospace news and facts.
Is it clear now? Why I played you the video to make you clear this concept of geosynchronous and the part of the sun synchronous orbit. Sun synchronous orbit is that orbit where it is a north to south polar orbit, and the plane of the polar orbit that moves, that rotates as the earth revolves around the sun, is almost having tilt of 0.8 degree per day. Now what you have seen in the video here, that there is another special type of orbit which I have already mentioned, that is a geostationary. So based on the movement of the satellite, there can be different types there, but for communication purpose we prefer geostationary orbit, right? So now if you see here the geostationary orbit, in terms of which is a special case in case of a communication satellite. Now geostationary orbit, what it comes here, that is see the difference between geostationary orbit and geosynchronous orbit is that geosynchronous orbit is an elliptical orbit. What type of orbit you find? this is elliptical. It is an elliptical orbit, right? And the time taken by the satellite to revolve round once round the Earth may not be the same time period of the Earth's rotation, right? Earth rotate approximately 24 hours, so it is not, may not be there. But when you talk about geostationary orbit, the first condition that makes a geostationary orbit is that geostationary orbit is a completely circular orbit, right? It is a completely circular orbit and it lies on the plane of the equator. This is the equatorial line, right? 0 degree line here. So here what we find is that the satellite moves in this kind of orbit with respect to the planar part. So what here happened here? The first thing is that it is a circular orbit. Geostationary orbit is a circular orbit. What is second thing here? Second thing is that here the height of the orbit, right? The orbit is located around 35,786 kilometer, that is approximately 36,000 kilometers from the Earth's surface, right? Approximately. Exact height is the 35,786 kilometer or 784 kilometers there. Approximately 36,000 kilometers above the Earth's surface, right? Third thing is that the satellite moves around the Earth here. Now it is here on an equatorial plane, right? What is the fourth aspect here? Here the synchronization of the direction. The satellite moves here. The direction of the movement of the satellite is west to east, that is the same as Earth's rotation. Earth also rotates from west to east direction. So the direction here is similar to Earth's rotation, that is the west to east direction. What is the fifth aspect of the geostationary orbit? The fifth aspect is the time period. The satellite take here the time period of completing one revolution around the Earth is here 24 hours, right? What it takes the one part of it. Now what is sixth part of the geostationary orbit? The rotation speed of the Earth rotation speed and the revolution speed of the satellite, they almost match each other. That means the time it takes for rotation, the same time the satellite also moves. So it remains fixed from a particular point on the Earth. So what happened here is that it matches here satellite speed, right? That match with the rotational speed of the Earth. Right? What is the fifth point here? The speed of the satellite which move in such kind of circular geostationary orbit and the rotation of the Earth, the rotation speed of the Earth, right? Both match each other, right? Then what comes here? So that means here, so what will happen here? It will look fixed. The position of the satellite remains fixed, relatively fixed from the, so here that is the position of a satellite remains relatively fixed from a point on the ground, from a point on ground. That's what it is used for communication purpose. That's what it is basically utilized for communication aspect. In terms of uplink and downlink aspect of it is used for communication purpose. Correct? These are 7 points regarding the part of it, right? Is it clear here? Are you able to understand? Just 1 second. I got a message that somewhere there was interruption in the classroom. क्लास स्टार्टेड फ्रॉम द बिगनिंग. एक बार देखिए क्या प्रॉब्लम है. लेट मी ट्राई टू रिजॉल्व द प्रॉब्लम. व्हाट एग्जैक्टली हैपेंड देयर. नहीं, स्ट्रीमिंग इश्यूज बोल रहे हैं वो. नहीं, कंटिन्यू करना है अभी. नहीं, बिगनिंग से या कैसे करना है. 5 मिनट पहले हुआ था तो मुझे रिपीट करना पड़ेगा. अच्छा ठीक है, चलो मैं कर देता हूँ. 1 मिनट मैं रिपीट कर देता हूँ. Okay, okay, I got the point. I'm just seeing your messages there. All right, I got the point. All right, I'll again repeat there. I will repeat again. Not a problem. I'll repeat again. Let me start here. Okay. See what I'm telling here. Now let's try to understand here. See, when you talk about geostationary orbit and geosynchronous orbit, they differ in one aspect is that geosynchronous orbit is an elliptical orbit, whereas the geostationary orbit is a circular orbit lying on the plane of the equator. In geosynchronous orbit, time taken by satellite to complete one revolution around the earth may change, maybe 1 hour, maybe it can move very fast, it can be 10 hours, it can be 20 hours, it depends on the distance of the orbit from the earth. Whereas the circular orbit, what happens, the distance of the orbit is approximately 36,000 kilometers, right? Is approximate distance, how much is that? 36,000 kilometers, or to be very precise, 35,784 kilometers, right? Now in this kind of orbit, the direction of the movement of the satellite is from west to east direction, which is same as Earth's rotation direction. That's the first type of harmonization or synchronization is there. Second type of synchronization here, that is in terms of the time period. Approximately it takes the same time period what Earth takes for one complete rotation, 1 day and night, that is approximately 24 hours. The satellite also takes the 24 hours. And third very important aspect of geostationary orbit is that the satellite speed of the satellite in its orbit, in the geostationary orbit, that match with the rotational speed of the Earth. Right? Let's say if the satellite here, its velocity of the satellite is Vsat, if I represent by Vsat, and the rotational speed of the Earth, that is a V rotation, that is the rotational speed of the Earth. So here in this case what happened, the satellite velocity will match with the rotational speed of the Earth, right? Satellite this one will match with the part of it. So it here, it matches with the rotational speed of the Earth. So what does that mean? That relatively as the Earth rotates, the satellite also moves from the part of it. So it always remains relatively here, the position of the satellite remains fixed from a point on the ground. That's what it is called geostationary. The word geostationary used, and it is used for communication purpose. It is used for communication purpose, right? Now what I am coming here, let me now come to the another aspect is that, इसको बंद कर दीजिए. Now based on the altitude or height of the orbit from the ground, from the Earth's surface, we can again classify satellite orbit in the following way. The satellite orbit based on the distance of the orbit from the Earth's surface, that is the altitude or height of orbit from Earth's surface. Based on that, the satellite's orbit can be classified in the following manner, right? It can be classified in the following manner. The first one, what is called here is low Earth orbit. Right? Low Earth orbit, that goes from up to 2000 kilometers. Right, from 100 to 200 kilometers to up to 2000 kilometers. that will be the low Earth orbit. Let's say if you place a satellite on in an orbit, whether polar orbit or equatorial orbit, whichever type of orbit you place there, if the satellite orbit is located somewhere around 400 kilometers above the Earth's surface, right, 600 kilometers above the surface of the Earth, it will be called as a low Earth orbit, LEO, right. Now, what type of applications are there? So, from 0 to 2000 kilometers, 1000 kilometer, 500 kilometer, 800 kilometers, that is low Earth orbit, right. Now, low Earth orbit here finds the following application. Now, the applications part, applications which are there with respect to the low Earth orbit are following. The first one is that it is used for remote sensing application, Earth observation, because since the satellite is near to the ground, near to the Earth's surface, so it can be used for remote sensing application. Now, remote sensing satellites are those satellites which have high resolution cameras, right, on board the satellite and is able to take image or photographs of the Earth. So, there the remote sensing or Earth observation being near. Another aspect is that we can also use for meteorological purpose there, meteorological satellite. In terms of the weather science and the meteorology, again the low Earth orbit can be a very good orbit for study of Earth's meteorology, the climate, the weather. Then at the same time here, low Earth orbit is also preferred for another very important application, that is in terms of space science and astronomical studies, right. Now, I will give you example here, I will just give you two examples here. Either it can be in terms of astronomical telescope, we can launch a astronomical telescope in low Earth orbit. Like let us say for example, I am giving you one good example of astronomical telescope. Let us say for example here Hubble Space Telescope. NASA has built a Hubble Space Telescope and was launched in 1990 to the low Earth orbit, almost around 400 kilometers. The Hubble telescope was launched. Now, Hubble Space Telescope has given an in-depth understanding of the universe, galaxies, formation of galaxies, right. That is where Hubble telescope has helped us understand. The astronomical telescope like a Hubble telescope, Hubble Space Telescope, just like satellite, it goes around the Earth. So, now NASA has already retired, right, US agency, NASA has already retired Hubble Space Telescope program, right. Now NASA is building more advanced telescope. One of the very important one which is making headlines is James Webb Telescope, JWST, right, James Webb Space Telescope. So, Hubble telescope, or it can be space science, and there can be also astronomical satellite, right. Astronomical satellites can also be placed in the low Earth orbit for observation of deep universe. Let us say I am giving an example here, ISRO, India's our own astronomical satellite, that is a AstroSat. In 2015, ISRO, Indian Space Research Organization, successfully launched AstroSat, that is India's astronomical multi-wavelength visible ultraviolet rays and X-ray rays based observatory or a satellite, astronomical satellite, which was built and launched successfully in low Earth orbit by ISRO. So, like one is the AstroSat. This last year in the examination, right, last year in the examination, there was a question, prelims exam, there was a question, ELISA, E-L-I-S-A, LISA. E stands for European, LISA stands for Laser Interference Satellite Group, which will study gravitational waves as given by Albert Einstein, right, in general theory of relativity in the outer space. So, here what comes here, AstroSat, or let us say ESA, European Space Agency's ELISA, right. Again the low Earth orbit is there. Another aspect where the low Earth orbit can be used, that is in terms of space station. Space stations are built in the low Earth orbit, right. We will find that space station is almost like a satellite which goes around the Earth, and they are built in the low Earth orbit. Like for example, presently the space station which is used is International Space Station, ISS. International Space Station is in low Earth orbit. around 400 kilometers from the Earth's surface, and it is managed by 5 space agencies: NASA from the USA, European Space Agency, that is group of European countries, Canadian Space Agency CSA, Canada, JAXA, Japan Space Agency JAXA, and then Russia's Space Agency Roscosmos. All these 5 space agencies, they manage International Space Station, that is in the low Earth orbit. That is the 5 agencies are there. Which so then comes China. China is building a its own space station, right, named Tiangong. What is the name of the space station of China? China is trying to build in the outer space, that is called Tiangong, right. India also has the aspiration to build a space station, but maybe that is in future, once we have successful human space program, human flights program, human space flight program, we can go for our own kind of space station also. Like China has got this Tiangong. China is building Tiangong as a space station, right, CNAS. Okay, there is doubt is there. Let me address the doubt. Then again, I'll come back to the classification of orbit there. The Pratik Dongre, he has asked the question that a sun synchronous orbit will have 0 displacement with respect to sun, but different position with respect to Earth. Good, very good. Because Earth is also revolving around its orbit. Yes, very good. Very good, Pratik, you are correct. What Pratik is saying, that Pratik has given a very important statement that a sun synchronous satellite will have a 0 displacement with respect to sun, because it tries to match in terms of direction of the sun, but it has a different position with respect to Earth from north to south, right, because the Earth's inclination part of it towards, and Earth is always revolving around its orbit, right, that's correct there. That's what I said, the plane of the orbit of sun synchronous satellite will move approximately 0.8 degree per day, right, you are right, very right, Pratik, you are very right. Okay, now let's come to the part again, what I have said here, and I'll give you the example, I'll show you certain examples here. Low Earth orbit is up to 2000 kilometers. It has got several applications. First major application is Earth observation, what we call remote sensing. Second, it can be for climate or meteorological studies. Third, it can be space science and astronomical studies. For example, there can be astronomical telescope. NASA in 1990 built a Hubble telescope, which is low Earth orbit, and then even satellite can be there, like India's own AstroSat is located at 650 kilometers. How many kilometers? 650 kilometers above Earth's surface, that is a AstroSat. European Space Agency is building ELISA, that is laser interference satellite system, which will study the gravitational waves as given by Albert Einstein in general theory of relativity in the outer space. Fourth aspect of the low Earth orbit is building space stations, right, like India has also aspiration to build a space station, but that is only possible when we have a RLV, reusable launch vehicle, and our human space flight. But which are there already made there? Presently ISS, International Space Station, managed by NASA, JAXA, Canadian Space Agency, ESA, right, and Roscosmos, 5 space agencies, they manage ISS, International Space Station. And then China is building its own independent space station named Tiangong. Right, what is the name of the Chinese space station? Tiangong. China is trying to develop that, right. So now let's look at here. I'll just go through it one by one. Hubble Space Telescope. Now whatever example I have given, I will take you to that part of it. It will come to your screen here. This one. When you visit the NASA site, whenever you read current affairs, see, when you read current affairs, you should always, let's say into a newspaper, you come across something on space exploration, something on that, you should immediately, do a search, Google search, and go to the website, let's say NASA here website, and read about that. Like here, you can see Hubble looks at black eye galaxy. That is what image you have, right? Now, if you see here, this is all development from comet makes a pit stop near Jupiter's asteroid, Hubble telescope there. When it was launched? 1990. it has 4 times service missions where the telescope was repaired in the low Earth orbit by spacewalk. If you have seen the movie Gravity, right, the initial part of the movie, the Hubble telescope was being repaired through spacewalk, and then space debris fell, and then the entire movie was based on that. So 1990 onward, it has given understanding of the deep universe, right. A lot of discoveries have been made, like about Hubble. If you go to this about Hubble, now you can see here. So NASA has already celebrated 30 years of the Hubble telescope, and you can see here, right, Hubble telescope, and it's just like a satellite. It goes around the Earth here. This is a nebula, right? It's gas and dust based nebula, which is image of Eagle Nebula. It is a Eagle Nebula, which was imaged by Hubble telescope, right? So it has helped us understand more about the universe, and that's what you find the information here. Now let's look at here. I'll not go to the entire part of this video, but some part I can play it here.
It has this direct window to the rest of the universe. There's nothing in between the rest of the universe and Hubble. There's not a single astronomer in the world whose life hasn't been touched by Hubble.
Hubble will be one of the great stories of all time. We will remember it with reverence, with the legacy, with the foundation. It gave us the optimism and hope to reach the bigger things. The world's most brilliant astronomers do miracles with this observatory, and it just keeps going on and on and on, and my jaw keeps dropping lower and lower with each new discovery.
Scientists around the world, together with science enthusiasts, the public, science supporters, came together to see here's an opportunity where if we put our wits together and our support together, we could build a platform that opens new eyes to the universe. Let's go for it.
Right? I said that I will not play the entire one, but at least I'll give you the glimpse of that, right? This is a Hubble telescope. NASA has built other type of telescopes also, like Kepler Space Telescope, built by NASA. The objective was to find out the Earth-like planet, super Earth or Earth-like planet, right? Spitzer telescope. There are a lot of such kind of astronomical telescopes have been built up, and they, just like a satellite placed in low Earth orbit, they go around the Earth. Kepler telescope is higher. JWST, now NASA is building now James Webb Space Telescope, which will be placed into Lagrange point. Now we'll be also discussing in the classroom Lagrange point, Lagrangian point L2 at the back of the Earth, 15 lakh kilometers. There the NASA is going to place JWST, right, in a high Earth orbit. But I just gave you example of a Hubble telescope from the point of view of low Earth orbit. Now let's look at here a very important part which I would like to take you to this part here. That is our own Indian satellite, that is a Astrosat. 650 kilometers, right? India's Astrosat has been placed. Is a multi-wavelength observatory of India, where our own achievement here, and you can see here ultraviolet telescope, which on the Astrosat has been able to take the image of the. But now see here, the first dedicated Indian astronomical mission, celestial sources in X-ray, optical and UV spectral bands has been now placed. And now if you see here, where it is placed, Astrosat with a lift of mass of 15 kilogram was launched in 2015 into a 650 kilometer inclined at an angle of 6 degrees to the equator by PSLV C-30 from Sriharikota. Now 2020, that was the decided time period or mission life of Astrosat. In 2020, Astrosat completed 20 years of its existence, right? This is our own achievement. And what kilometer you can see? 650 kilometer orbit. That is a low Earth orbit. That is a low Earth orbit, right? So that comes into that. Clear? Now space station, I have mentioned about space station, and I have given you that example of International Space Station, right? International Space Station, and you know that astronomer which goes to International Space Station, and they carry out a lot of experiments in zero gravity or microgravity, right? Now this is you'll find here the space station which is built on the low Earth orbit, right? And lot of details can be obtained, lot of experiments in zero gravity can be conducted in International Space Station, right. Is always manned by a crew member. There is always a crew member, and astronaut goes there and stay in the space station, right, in such kind of microgravity, and they conduct various experiment on the part of it. And it is also kind of understanding different phenomena on Earth. At the same time, it also helps us see the deep universe, because International Space Station is in outer space, and we can see that. Let's look at here animated view of International Space Station.
Hi, I'm NASA astronaut Megan MacArthur. Did you know there's a research laboratory in space? It's the International Space Station, and it's a scientific stepping stone that's enabling us to explore farther into space while improving life on Earth. The space station provides a unique environment of microgravity, extreme conditions, and an observation platform that enables researchers from all over the world to test theories and technologies off the Earth in an extreme environment unlike any other. We welcome you to join us on station. You don't have to be a rocket scientist or part of NASA to gain access to this unique laboratory. Don't know much about spaceflight? That's okay. We're here to help people just like you every day. You might be curious about funding, capabilities, access, or maybe you just don't know where to start. Give us a call or email. We'll ask you some basic questions about your objectives, which will help us point you to the right people who could make your experiment or testing your technology possible in space. Visit nasa.gov/station opportunities for more detailed ideas, answers, and contact information, or find us at the
Right. So, I have just played this small documentary which is given there in the International Space Station part of it. So, now what is the purpose of building ISS? What is the purpose of International Space Station? You have seen in the documentary here. So, space station, if you look at here, so space station's utility earlier Mir space station was built by Russia, right, which is again dismantled and all. Presently is the International Space Station. So when you talk about space station, the application part of it, the first thing which comes here about the space station is that it is a microgravity. It is basically a microgravity experimentation lab, right, where we can conduct several experiments in zero gravity, right, whether it is a microbiology or growth of bacteria or artificial photosynthesis. We can carry out various type of experiments that can be done in the such a kind of a natural lower gravity, zero gravity or microgravity there in the outer space, right. Now second is that space station not only help in conducting experiments in zero gravity or finding out any aspect of that, it also is basically a space observatory. Right? It also serves as a space observatory where the data regarding the galaxies or any part of the deep universe can be collected, can be studied, and the scientists will get to know, understand deeper part of the universe. So it also acts like a space observatory. Third is that one can also, same as the Earth observation, remote sensing, one can also have the data collection of the Earth, like continents and the oceans, various aspects can be done from the space station which is located in the low Earth orbit. So here in terms of Earth observation. Another very important utility of a space station is that it is basically a terminal. As we have a bus stand or railway station or airport, it is also kind of a terminal in the outer space which can support any space voyage or space mission. So this is a space terminal, right. It acts as a space terminal, right, to support space voyage. Maybe in future again there is a proposal to land man on moon, like already Apollo mission where the human astronauts which were landed on the moon, like Neil Armstrong and Edwin Aldrin. Now there is again a proposal to getting back to the moon, right? There is also international proposal in terms of having a mission where man should be landed on the red planet Mars, right? Mars and the red planet has been a fascination for space agencies, and a lot of studies have been done. Recently, the NASA has successfully landed a rover Perseverance, right? If you have watched this movie Martian, right, Matt Damon Martian movie, you know that they're trying to take the man to the red planet. So even that can be a kind of terminal to support space voyage, right? Space exploration, space voyage. Now another aspect of the space station is that space station is also a kind of a workshop in terms of repair. It can do repair and maintenance. Like I have mentioned that Hubble telescope, which was placed in low Earth orbit, where was repaired right from time to time. It was maintenance was done from time to time through the spacewalk. So that can be done with the help of space station. So what can be here? It can be a repair and maintenance. It can be used for repair and the maintenance. As a workshop, it can work on that, right? That can be a part of it. At the same time, now that Elon Musk, right? Elon Musk, who is the owner of a very important company called SpaceX, right? SpaceX has developed a human space flight rocket launch vehicle, Falcon 9 Heavy. SpaceX has built a reusable launch vehicle, RLV, named Falcon 9. And such kind of private entity like SpaceX and the others are trying to get into space market, and they have also one very important kind of a future program in terms of taking human being to the outer space, bring them back. What is called space tourism. The next part which can come there, that is in terms of space tourism. That may be a future after 20 years or 30 years, this can be another one. Today it is not possible because of the kind of risk involved in going to the outer space. It requires high level of training to go to the outer space, live in the space, coming back there, right? And it is very, very expensive, very costly. But who knows, maybe after 10 years, after 20 years, after 30 years, space tourism can be a viable aspect, right? So that can be the part of it. Now China is trying to develop Tiangong, right? This I have given the general aspect of that. China is trying to develop the Tiangong. Now Tiangong, China independent space station, there can also be military, in terms of its own kind of national aspect, China can look into that. India also want to be going to the space station program, right? So that is you should know where the application can come, right? That becomes very, very important. There is a student called Jaydev Pathak. I can read his statement in the response screen. Whatever you respond is visible to me and I am able to read that. So Jaydev Pathak has made a statement here in the response part that it is necessary, otherwise aliens, people from other planet will attack on us one day, will destroy this human race from earth. So this is the statement made by Jaydev Pathak. Is it true? Let's say if UPSC asks question, right, and already a question has been asked in the main exam. What was the question in the main exam? In terms of India's space station program, like India, shall there be a space station for India? This was the question in the main examination. Or let's say if you have to write an answer, the application of space station, will you write this point of Mr. Jaydev Pathak? Jaydev Pathak has that will protect us from aliens and this and that. Will you write this in mains answer? Will you write this in mains answer? Jaydev, I am asking you there. You have made this statement. In what context you want to make this statement? My point is that if you have to write the answer in the main exam, will you write that? Space station is necessary. Why? Because it will protect us, human civilization, from any attack from the alien. UPSC exam is not a science fiction movie. You write the movie aspect and you will get 10 out of 10 marks. space station has been built with some kind of important applications. There's already a controversy and dispute that whether alien is there or not. That's another thing there. But in the examination, when you are in the UPSC mode of examination, you have to first look into the immediate application of any technology. Where you have to focus, how the technology, the immediate use can be there. Let's say Gaganyaan mission, human space flight mission, right? Why India want to have human space flight mission? Why we want to have the Gaganyaan mission? So that 3 Indian astronauts will go to the outer space and will say hi and hello to aliens. Hello alien, we are Indians here. Huh? So you should be careful when you write anything on the response screen, right? And there has to be a bit of seriousness in the classroom. At the same time, I am discussing a very important subject here. I'll tell you that there are some students who think they are very over smart, right? And when the question comes in the exam are very important areas, and remember that whatever topics I am highlighting in the classroom, I am discussing, they are all very, very important for coming prelims exam. But there are students who neglect or overlook there. And they have to pay heavy price during the examination hall, where they make blunders and they fail in the examination. Is it clear here, application of space station? Elon Musk is a great man, right? What a great man like Elon Musk, and all this kind of irrational statement made in the media doesn't hold any kind of ground with the civil service exam. Right? I have already said that there is already a controversy with respect to whether alien exists or not, or something, what happens in that part of it. Right? That is not the part here, right? That's right. I know that what you are saying, that Elon Musk has a dream to make a human being as an interplanetary species. That's correct. But that is not from the UPSC point of view. I am talking about from the, if let's say question comes in the UPSC exam, will you write Elon Musk, that human being being an interplanetary species? Will you write this in the mains answer to get marks? See, when you have to write anything, then you have to look from there. That's right. I am not saying anything against you. I am not saying anything wrong there, right? What you are saying is correct based on the media report. You protect the human race from the alien and all what Elon Musk says. Forget what Elon Musk. One Harvard University scientist said that alien exists with us. It was also in the news. A Harvard professor, right, he told that there is already alien with us, just like Man in Black, MIB. That can be kind of personal statement made by any XYZ. But you have to know from the real utility of the program, where the real utility, real aspect of that particular program comes into that. That you have to be focused on that, right? You are right. What statement you are making, that is correct. What Elon Musk has said, that to make human being as an interplanetary species. Elon Musk has very, very weird ideas, right? So that is something which comes in media, right? And media is not always the true, and media is not always the correct. A personal opinion may not be always correct, right? But when it comes to science, when it comes to technology, when it comes to the facts, when it comes to the application, you have to look into real application. A fictional application, that can be something, who knows, maybe after 100 years or 50 years. But what is the first thing is the real application part of it, right? So I have explained here that the real application of space station comes from here. Now what is the challenge here? If China builds its own space station, among all these applications you can also add here the military part of it. If China has its own independent space station, then China can use it in any manner. It can be used for reconnaissance purpose, gathering information, gathering the data, gathering the information, spying purpose. It can be also for military aspect also there. So that can be part. So India, if China will develop, China is developing Tiangong as a space station. India also want to develop it. But we have to have that kind of capability. China has a manned mission. India still is struggling to have Gaganyaan mission. Right? We are still struggling for that particular mission there. Right? But maybe in future, India will also build space station. And there it can be also for the military application, can also be part of it. Alright. Now what I am coming here, apart from this, now what comes the next part here in terms of altitude, that is a medium earth orbit. Second type of classification is MEO, medium earth orbit. Now medium earth orbit, that extends from 2000 kilometer. The range of the orbit from 2000 kilometers to approximately up to the 35,784 kilometers, where you have a geostationary orbit. Any orbit at 10,000 kilometer, any orbit at 12,000 kilometer, 15,000 kilometers, 25,000 kilometers will be called as medium earth orbit. Now the medium earth orbit, in terms of applications, if we look at for the application part of it, the first application which comes here for medium earth orbit is the navigation purpose. Navigation satellites, they are kept in medium earth orbit, right? Navigation satellites. And you know that one of the very important application what comes from navigation satellite, that is a global positioning system. GPS, right? There are regional positioning system also there, right? GPS or regional positioning system, that is based on navigation. What do you mean by navigation? When you use the word navigation, navigation is in terms of direction, location, precise location or a range of the location, right? Navigation is also not only finding a direction like east, west, north, south, whatever directions are there. When an object moves on the earth, on the land, on the sea, under the sea, in the air, right? There the navigation comes, but also it comes to timing. It also looks into the timing part of it, right? Now the navigation satellites, they are used in the medium earth orbit, and if you take the examples here, you know the examples here, right? America, USA. USA's GPS, popularly called GPS, but the name is Navstar, navigation satellite and ranging, right? Then Russia, the next GPS which comes here, Russia. Russia has got Russia's GPS, that is called GLONASS, Global Navigation Satellite System, right? Then European country, Europe, they have got the Galileo, named after scientist Galileo Galilei. China has a regional navigation system, what is called as here Beidou or Baidu. Chinese regional navigation system, that is Baidu 1. Now China is building to develop from regional to global position system. China is building that. Then comes India. India has successfully built Navik, navigation with Indian constellation, which is a IRNSS, Indian Regional Navigation Satellite System, right? We will discuss that. I'll go in detail part, don't worry. What is Navik? We are going to discuss the detailed part of it, but just I am giving examples. First I am giving you examples. We'll see the Navik there. Navik, navigation with Indian constellation, or it is called Indian Regional Navigation Satellite System, right? Japan. Japan has got QZSS, Quasi-Zenith Satellite System, Quasi-Zenith Satellite System, QZSS. That is Japan's regional navigation system. These are the operational type of GPS and regional GPS. America and Russia have got in two sense GPS which has a global coverage, right? Europe has developed Galileo. Now regional level China, Baidu 1. Now China is expanding to make it global with Baidu 2, India has built Navik at this point of time, but in future we may also go for a complete GPS kind of it. Japan has got QZSS, Quasi-Zenith Satellite System. The first application of medium Earth orbit is to place navigational satellite in the outer space, right? Now, navigation satellite or GPS, it helps in providing us direction, location, timing. These are three dedicated services, right? And there are two ways where the GPS work. One is called Standard Positioning System, SPS, and second is called Precision Positioning System, PPS. Standard Positioning System, it provides a range of range area. But when we have to have exact location, when we have to track exact location of a moving object, we go for Precision Positioning System, where the exact position of a moving vehicle, car or train or let's say aeroplane, is tracked with the help of a satellite there. So there are two aspects which comes here. Civilian application, where we as use every day with Google Map, when we navigate with the Google Map, that is civilian use, or we find out the location of any place, let's say ATM or a bank branch or any destination which we want to go into that place, we can find out using Google Map or GPS part. At the same time, when we navigate through railway or train or the buses, again the navigation comes there, right? GPS system comes into application part. At the same time, we also have restricted application of GPS, where military application, where we have to use missile, guided missile, Agni, Prithvi, BrahMos, all those kind of guided missile system. They have to go to the designated target, and for that GPS is a very, very important application. Fighter craft, bombers or fighters, whether it's a Rafale or MiG or Sukhoi or India's LCA Tejas, light combat aircraft Tejas, again requires the GPS system to work, right, which gets support through radar and the sonar system there. So GPS becomes very important for military application, where we require very, very precise position of the target, right? Military application restricted. Why India went to develop own indigenous regional GPS system, NAVIX? Because of the neighborhood. During Kargil conflict, during Kargil war, right, with Pakistan, America denied services to India, particularly for the military application. We had a very challenging time during the Kargil conflict and the war, that for military application of the GPS services which we were taking from America, and America didn't allow India to use that. We realized our vulnerability, how vulnerable we are depending on other countries' GPS. So Government of India took the stand, let's build our own regional navigation system, so that our military services, Army, Air Force, Navy, they get supported through the satellite mode there, right? That's where the NAVIC comes. But NAVIC will also be used by, we all Indians can also use the NAVIC system, right? Now what comes here, apart from this navigation part, what comes the second in the medium Earth orbit? Just above that, what comes here? When we come to 35,784 kilometers, there is a special type of orbit called as a geostationary orbit. So what comes the next one is the communication satellite, right? Broadcasting, right, in terms of having tele-education, telemedicine, all those kind of satellite communication, SATCOM. So that communication satellite here, where it comes here? It comes here in the geostationary orbit, that is the 35,784 kilometers, right, 36,000 kilometers. There we have the circular type of orbit called as here, right, and that is for where the geostationary orbit comes into that. Now apart from this one, the third type of orbit in terms of the altitude and the height, that is a high Earth orbit. What is third type? Third is the high Earth orbit. What is high Earth orbit? High Earth orbit is that orbit which lies above 36,000 kilometers. Based on altitude, we can classify the orbit as high Earth orbit, HEO, any orbit which lies in 50,000 kilometer, 1 lakh kilometer high Earth orbit, right? They are basically meant for space exploration program. Where we use it? We use it for space exploration. So again, I'll repeat here. Based on altitude and height of the orbit from the surface of the Earth, we have three major classification: low Earth orbit up to 2,000 kilometer. Then we have a medium Earth orbit, 2,000 to 36,000 kilometers, navigation, communication, and then we have high Earth orbit, more than 36,000 kilometers, which are used for space exploration part of it, right? So this is the first, in terms of giving you idea regarding the orbit, right? Right? इज इट क्लियर हियर? इनको पूरा व्हाइट बोर्ड दिखा दीजिए आप. Please copy whatever I am writing there, so that whenever you refer back to your class notes, you can at least know that this was discussed in the classroom there. Any doubt, any question you can ask me. We will discuss about GPS and the Navig system in more detail. Don't worry about the detailed part, I will be coming to that. First, I gave you a general understanding, a concept about the classification of orbits and the different terminology part of it, right? If you have anything to ask with respect to here orbit, you can ask me. Okay, there is one question here coming there. Okay, first part is not visible. So हाँ वो पहला part उसको पूरा अच्छे से, just one second. I will remove the podium from here. So maybe you are able to see that. इनको sequentially दिखा दीजिए आप एक एक करके ना, ताकि ये students जो हैं वो लिख सकें. Any doubt, any question you have? See, I have given you in a sequential order. It's up to you how you write that. How you put across in your class notes, that's up to you. How do you write all the points there? इनको दूसरा पार्ट दिखा दीजिए. अच्छा ठीक है, आप those who have not written, please write it down. हाँ. Done? Everybody has copied it? Because now it will be removed from the whiteboard. So please make sure you have copied it. Okay, it is written there. That's right. Thank you everyone, like you have been following the things. So let us now understand here. I have said here the China is trying to develop its own kind of, so let us now just give you idea here. This Tiangong system there, right here, this is a Chinese National Academy here, right. This you will find in the, when you go to the Tiangong missions here, right, you will find in Britannica and even in the Wikipedia all given there, and this is the directory of that part of Tiangong 2 and all this. So even it came in the Indian Express also there, the news was there. Right. So Tiangong 2 was a manned Chinese space station that was destroyed upon its controlled re-entry. It was dropped to the ocean, Pacific Ocean on July 19th, and that's retired in that. So China is still trying to develop that, trying to develop that part, and you can read from the news and all. Now this is the, you find the description of the Tiangong there. It was asked in main exam that what is the value, what is the importance for having space station for India, right? So our neighbor is developing this one. That can be a one way where it can be perceived threat for India. So that's what comes. So now see, Tiangong is an 8,500 kilogram or 18,700 pound cylinder that is 3.4 meters in diameter. It has two sections, that forward pressurized and all. Not too much of technical detail you have to go into that. But then only we have to know that they have been developing that, right. Now another thing from China is that this their regional navigation system, Baidu, this one. Right. You can see the image has also been given, like and you can, if you see the image properly, there is the entire constellation of the satellite. You will find all the satellites which are there going around in different orbit there. So this is about the system here. If you just go to the system of China's Baidu navigation system, now see what is given here. I'll just go through it there. Baidu navigation satellite system, BDS, is an independently constructed and operated by China to help them in national security and economic social development. And you can see here, this is a widely used in transportation, agriculture, forestry, fisheries, hydrological monitoring, meteorological forecasting, communication, power dispatching, and all this application has been given there, right. So now China is going for the global aspect, from regional to the global one, right. By 2012 it has developed this satellite system. And then coming to India, India's Navik, navigation with Indian constellation. Initially we developed as a 7 satellite system, right, 4 in geosynchronous orbit and 3 in geosynchronous orbit, right. India's navigation system, IRNSS, the initial group of satellites, right, that is it looks like this one. You can see this image here. 3 satellites placed on geostationary orbit. What is geostationary orbit? That is the equator, lying on the equator. And the other 3 of them in geostationary orbit and 4 satellite which makes looks like a 8, number 8, for geosynchronous orbit. This is the constellation which forms the Navik there, navigation with Indian constellation. And you can see here, this is the, it will help provide the user the information, right. Navik has been designed to provide accurate position information to users in India as well as the region extending to 1500 km from its boundary, primary service area. Not only within the country, the GPS services can be provided by IRNSS or Navik, but it can also extend to 1500 kilometers beyond the border, right? There was a question asked in 2018 prelims exam. UPSC has asked question on NAVIC or IRNSS both in the prelims exam and the main exam. And there was a question asked in the prelims exam in the 2018 where it was given that 9 satellite system. That is wrong, 7 satellite system. 3 geostationary, 4 geosynchronous. One another part of the question was the fact that it has area more than 5,000 kilometers. Now if you see here, the primary service area where it can be used, it can be also given to our neighbors. Let's say Nepal, Bhutan, Bangladesh, they can also use 1500 kilometers, it goes there, right? But what is very important, I would like to highlight here, I would like to highlight this part. Extended service area lie between the primary service area and area enclosed a rectangle, right? From latitude 30 degrees south to 50 degree north, longitude 30 degree east to 130 degree east. So if you see here, it basically has, if you talk about area part, if you just see the area, we can have extended distance of 1500 kilometers from the borders, but I am talking about area of coverage. This rectangle what it talks about, that will go well beyond more than 7,000 square kilometer. I am talking in terms of area, how much area can be covered. Area is the length and breadth. There is a big area which can have the coverage of the navigation by the NAVIC or IRNSS, and that can be more than that. Now see here, what is said here? 2 types of services. Standard positioning, SPS, which is provided to all the users, and then precision position system, restricted services, encrypted service provided to the authorized users. Who are the authorized users? Authorized users here are government agencies, right? Military establishment, Army, Air Force, Navy, or the government agencies which require such kind of a navigation kind of data or the services, right? Restricted services. And 20-meter range, it has a accuracy of better than the position. It can provide a position of accuracy better than 20-meter in the primary service area, its main service area. Why I have opened ISRO site and I am discussing right now in the classroom? This is where UPSC asks question. This is the information on the ISRO website, and based on that the question setter of UPSC, they set the question. I have found many times that most of the materials are generally from copy paste from the newspaper and those comes into that. But whenever you talk about science and technology is very dynamic area, linked with current aspect. You have to go to certain website, government website. I am doing this exercise in the classroom. Today is the 3rd class of science and technology, just to make you aware. If you really want to solve questions correctly in the exam hall, you need to visit such kind of website, right? You will get the exact information. Better information will be given which can give you understanding, and you can easily solve the correct answer with the correct option in the multiple choice question in the prelims exam, and can write a very good answer in the main examination, right? So what is accuracy here? Better than 20 meter in the service area. Now application part is not only that can be used for part, but it has several applications. Terrestrial, aerial and marine navigation, like road traffic, road navigation, railways, right? Airport, Gagan system. Now there we have now developed another system called Gagan. So any kind of navigation we can use. Gagan is a different type of system. I will explain what is Gagan in very soon, but Gagan is different one. But Gagan is also linked with navigation for civil aviation part. But here what is given? Terrestrial, aerial and marine navigation, disaster management, vehicle tracking and fleet management, integration with mobile phones, we can use in mobile phones, precise timing. How the timing is given? Through the atomic clock. Initially India developed more number of satellites. We have launched 9 satellites. But what happened? A few of the satellites with the atomic clock, which gives an accurate time, that became non-functional. There was a problem with respect to atomic clock. So those satellites were replaced with a new satellite. Actual constellation consists of 7 satellites, right? Now what is given here? Terrestrial navigation and for hikers and travelers, visual and voice navigation for drivers, let's say Ola cab, Ola, Uber, all those kind of, they use the GPS, right? They use the GPS part of it. Defense also can be, now see here. So it's given here INSS signal in space, control document is there, standard position system, and all is given there. Spacecraft messaging service. See, INSS 1A spacecraft provide messaging service to users in the Indian region, right? So it is given here. So you'll find the information here, right? You'll find all of them. See here, if you do the counting, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you see that? If you see the number of the satellites, there 9 are there. Many students, they made blunders. They got the wrong answer in the exam. Exact number on which this Navik works is 7 satellites. But then 2 satellites, there was a problem with the atomic clock. Where the problem happened? It happened with the cesium. There is cesium atomic clock that went wrong, non-functional in 2 of the satellites. That's what we have to add additional one. But the exact constellation is with the working with 7 satellites, though we have launched 9 of them. How many of them are in geosynchronous? There are 4 in the geosynchronous. And how many are there in the geostationary? There are 3 in the geostationary. 3 in geostationary, 4 in geosynchronous. Clear? Did you understand this one? Why 9 satellites? INS 1A, 1B, 1C and 1D. Because initially the satellites, there were problem with the atomic clock. That's what we have to add furthermore 2 of them. But exact constellation is made up of 7 satellites, which you can see here in the diagram here. Four are in geosynchronous and 3 are geostationary. So did you understand here? 1500 kilometer from the border area. But again, if we talk about swath or area, area is a huge one. Length and breadth, if you multiply, the area will be more than 5,000 square kilometer. Clear here? All right. So what I'll do here, I will be giving you a small break here so that everything gets fixed and everything, let's see that things are there. So I am giving you a reference. Remember that in my class, you have to be very, very active, because I have said that in the science and technology class, I will be linking with current aspect. I will be providing you certain informations which are linked with current aspect. And I will be opening a lot of website. I will be taking you to various sources like Tiangong. I have discussed about Tiangong. Maybe possible UPSC can ask question. Navik question already has been asked. Whatever has been asked, that is asked. UPSC is not going to repeat the question. Now you have to see which are the topics where questions have not been asked in the space science and technology. And there you have to focus that, right? So all those sources, whatever I will be referring to the classroom, please make note of that, right? It may come in the exam there. Now what I am going to do here is that after the break, we will discuss about Lagrangian point, a very, very important point, Lagrange point. And we will discuss about Aditya mission of India, Aditya L1 mission, Lagrange point. And then we will go to the launch vehicle technology. We will discuss about launch vehicle technology. All right. Let's have a 10 minutes break and we'll get back to that. We'll discuss about Lagrangian points, Lagrange points, and then we'll go into the Aditya L1 mission of India space program, and then we'll start discussing about the launch vehicle technology. Right. Let's have a 10 minutes break and then get back. Okay, there is a question from Arjit. Arjit is asking me a question that in spite of ISRO, there it was written 8 satellites given, why it was so far. Please if possible explain a bit for. Okay, I said that in the ISRO site, if you see there, you'll find that it is mentioned that, but there see the GPS satellite. The GPS satellite carries a atomic clock, right? Now atomic clock is used to provide the precise location time. Any object which has been tracked by the GPS, right, in terms of navigation, the timing of that location, right, that can be done through the satellite, and it is done with the help of a very precise, accurate atomic clock. Right, either they are made of cesium atom or rubidium atom. Now what happened initially when ISRO launched the satellites there in the orbit, initial satellite, there were two of the satellites where the atomic clock didn't work. So in that context, those two satellites we have to supplement. We have to supplement with two additional more satellites with the correct and accurate functional atomic clocks. That's what you find 9. And what Arjit is saying that 8 was given. But what I said, the real constellation will consist of the 7 part of it. Now if you see here further, if you look at here, I'll just do this. This is the first one, the geostationary orbit, GSO. Let me come to this part of it. What you can see, this line. Okay, this is the part of the equator. So you have one geostationary orbit, one satellite is here, right, GSO1. Second you have here GSO2, geostationary orbit second, right, that's given, and one more will be third one. Now if you see here, third one is this one. If you see here, this one, 6, say here 1, 2, 3, 4, you have got the number also there, and 6 and 7. If you can see clearly this diagram, you have 7 satellites. 3 of them are on geostationary orbit, and the 4 which makes a kind of a number 8, they are in geosynchronous orbit. And if you can see the area, it covers the entire Indian landmass, right, the entire India, plus it also goes beyond 1500 kilometers from the borders, right, 1500 kilometers from the borders it can follow that. And if you see the area which is covered here, area is a huge area which is covered. There can be navigation up to Iran, and you can see Red Sea. This is a part of Red Sea, right. The Navig can have coverage till the Red Sea, and it also covers the part of China and this part of the Southeast Asia, like Philippines and the part of Java, Sumatra, it can cover there, right. That's what I said, it is 7 satellite system. 4 on geosynchronous orbit and 3 in geostationary orbit, right. So that's what I know that sometimes the students may have doubt with respect to number of satellites, right. So that's what I clarified here. Now what I'm going to discuss here in the classroom, a very important topic. Let's look into the Lagrange points. Right. Another very important part for your examination. This is the important for UPSC exam, and you could get a question in the examination. UPSC has not asked anything related to Lagrange point or Lagrangian points. Now this concept of the name Lagrange, right, it was given by French mathematician Joseph Lagrange, right. The name Lagrangian point, that is given by French mathematician, that is a Joseph Lagrange. Now what is the concept here? The concept of Lagrange point is that there are 5 points in outer space, right, with respect to 2 heavenly bodies. If we take 2 heavenly bodies, Earth and the Moon, Earth and the Sun, Jupiter and the Mars, Jupiter and its Moon, any 2 celestial bodies, any 2 heavenly bodies, with respect to that 2 body system, there are 5 Lagrange points. Right, there are 5 Lagrange points where the net gravitational force or net force due to gravity and the forces of the centripetal centrifugal, that gets balanced. and an object which is placed there, a spacecraft or a satellite placed into such a Lagrange point, will remain stationary with respect to Earth, with respect to one heavenly body. So, what is Lagrange point here is that the first point what comes here, that there are 5 Lagrange points, Lagrangian points with respect to 2 body system, two heavenly bodies, let us say Earth and the Moon or Earth and the Sun. It forms a kind of 3 body problem there, right? 2 heavenly bodies, such as, let us say we take Earth and the Moon system, right? Earth and the Moon as the 2 heavenly bodies, or let us say for example we take Earth as a planet and Sun or star as a system there. Right? Now let us say for example we take Earth and let us say Moon, Earth's moon, right? So the Moon goes around the Earth in 28 days, right? There's a, so what it says here, if you take Earth and the Moon and we look at the Lagrange point here, so we find 5 Lagrange points. The first one will be between Earth and the Moon. This is called L1, and equidistant from L1 to the Moon, if you take the other one at the back of the Moon, there will be L2 point. Third will be back of the Earth, and the fourth and the fifth Lagrange point L4 and L5, that will make 60-degree angle with respect to the Earth. This I am talking with Earth and Moon system. Right? Same way, if you take Sun and the Earth, if you take Sun right, sun and the Earth system, right, and we can again here find five Lagrange points here, right? We can find 5 Lagrange points. So the first Lagrange point will be between Sun and the Earth, this one L1 point, and equidistant at the back of the Earth there will be another Lagrange point L2, and the third one will be at the back of the Sun, L3, and the fourth and fifth will make 60-degree angle with Earth, with Sun, just almost like an equilateral triangle. Right? These are the 5, and this we are talking from 2 heavenly bodies, Sun and the Earth system. You can take any 2 heavenly bodies, right? And these all points shift in the space. They are not stationary. As the Moon will rotate around the Earth, or the Moon will go around the Earth, these all 5 points will also move together with respect to the Moon. Same way, as the Earth revolves around the Sun, all these 5 points with Earth and the Sun system, they shift. I will show you with the diagram there. It will move with the part of it here. Now what is said here, that L1, L2, L3, what do we find here? The L1 point, L2 point and L3 points, right? They lie on the straight line. Right? Whereas the L4 and L5 points, right? They make an angle of 60 degree. Right? Now what happens here is that there are two types of forces happens when a body move in the outer space. The first type of force is the gravity, the force of gravity, gravitational force as given by Newton's law of gravitation. And second type of force is because of the rotational motion, so there will be centripetal and centrifugal forces. And centrifugal forces, they balance each other, and the necessary centripetal force is given by the gravitational force. So what happens in this case is that let's say if you take L1 point and you place a satellite here, so there will be a gravitational force of the sun acting this side, and there will be gravitational pull of the earth on the other side. At the same time, since this body also revolves around this one, so it will also have its own kind of the centripetal force. So that gets counterbalanced. So what happens, the object which will be placed here will remain fixed with respect to the earth system. There is something called a concept of halo orbit. What orbit called as a halo orbit? Halo orbit is a three-dimensional space. It's basically not a point, it is basically a three-dimensional space where the object which is kept there will keep on moving there. So let's say for example here in this context, so what happens in this, net force get balanced, right? So what happens on all these points here, the net force which comes here balance on these points. Right? Now understand a very important concept. When you place at L1, there is a force of the sun, right, towards left, and there is a force because of earth on the other side. Let's say there is a displacement, there is slight disturbance and displacement, the spacecraft, satellite move away from this point. Then the total force which will be acting on that object will change. So what happens in the case of L1, L2 and L3 point, which are on the straight line, there it is a unstable equilibrium. What comes here? This is the unstable equilibrium. What do you mean by unstable equilibrium? Unstable equilibrium means if there is a slight displacement from the position, it will not come back to the position. Whereas the L4 and L5, it forms a kind of a counterbalancing like an equilateral triangle. It forms like an equilateral triangle here. So one force is here, another force is here. So if there is any kind of displacement from L4 and L4 point, L5 point, it's just like a simple harmonic motion, SHM. Right? You will try to again bring it back to the position. So L4 and L5 points, they are called stable equilibrium. They bring into stable equilibrium. If there is any kind of a displacement, so again the forces will work in that, it will spring back, come back to the L4, L5. Same here also. Right? But if there is anything happens at L1 point, if it goes left or right, then it will have such kind of a disbalance there, it will not be able to come back to the point here. That is called unstable equilibrium. L1, L2, L3 are in unstable equilibrium. Why they are in unstable equilibrium? Because if there is any slight displacement from L1 or L2 or L3 point, what will happen? The forces of gravity will change. The satellite or spacecraft will not be able to spring back or come back to the position. Unstable equilibrium. On the other hand, L4 and L5, 60 degree angle like an equilateral triangle here. So whatever the forces are there, if there is any displacement left or right, the forces will work in such a way that net force, resultant force will again spring it back to the L4 point. They are L4, L5 are in stable equilibrium. Now let's look at here how it works. Let me draw a diagram here. इसको बंद कर दीजिए. Now let's look at the, I'll explain with one single point, you will be able to understand here. Let us see here what exactly, if we take sun and earth system, right? If we take sun and the earth system, what we find here, if we take one point here, let's say this is sun and this is the earth, right? And let's say we draw the straight line here, all right? And let's say, for example, if we focus on L1 point, and let's say in L1 point you have a satellite here or a spacecraft. I have drawn the satellite here, right, or spacecraft. Now what will happen here? As the earth revolved, right, as the earth revolved around the sun. Let's say earth revolved and earth comes here. You'll understand what is how the points change in the space there. Let's say after few days the earth revolves and now earth comes here. So again you draw a straight line here, right? So what will happen? This L1 point will come here. Now as the earth revolves around the sun and earth comes here, after again number of days earth comes here, again you draw this straight line, L1 will be here. As the earth revolves and comes to this point, right, again the L1 point will come here. As the earth revolves and come to this point, again L1 will come here. So what is happening here? With the earth, this L1 point also moves in the outer space. That means it is almost looks like that earth and that satellite at the L1 point, they are tied with a like kind of rope or a string, and they both together goes around the sun, right? Let me now explain with another diagram here. If we take L2 point, let's say for example, if I take L2 point, now let's look at here L2 point. I'm taking here L2 point here. Where is L2 point? L2 point is the back side of the earth. This is L2 point here, right? Now let's say we place a satellite here. Now as the earth will revolve, let's say earth comes here, right? So again you draw the straight line here, right? So where the L2 will come? L2 will come here. That means this point also moves with the earth. Now as the earth revolves and comes here, again you draw this straight line. Right? Where the L2 will come? L2 will come at here, back side. Right? As the earth revolves here, comes here. Again the L2 will come here at the back side. Right? As the earth revolves and comes here. Right? Are you able to imagine here? So with the earth, the point will also move. The point will also move in the outer space. So earth and the L2 points together will go around the sun. This is what requires the imagination part, right? Now what comes here, the very important point. Here the concept of halo orbit. What comes here? A halo orbit. there is a concept of halo orbit. What is halo orbit? Halo orbit is a three-dimensional space. I'll depict with a diagram that will make you more clear what a three-dimensional orbit means here. So I said that it is not a orbit, it is basically a three-dimensional space there. It's like this one. Right? What is a halo orbit? You will understand there. Let me explain with the L1 point. So it is not a point here. It's not a point here. It's basically a this type of orbit. Imagine that there is a orbit lying here, and the satellite is not like on the point, but satellite is going like this one. This is a concept of halo orbit. Here I have explained you with respect to point. Why I have explained with point? To make you understand, to make you imagine how the points move with respect to Earth. That's what I have used the point. But actually it is not a point. It is basically a three-dimensional space. There is a three-dimensional space. It is basically an orbit where a satellite moves like this. It's nothing like a point going around like that. It's basically a part of. So as the Earth will go around here, as the Earth comes here, again you can say that it will be kind of a halo orbit here, this kind of orbit. Right? As the Earth comes here, right, again there will be a kind of a halo orbit here, where the satellite moves here. Right? It moves in this particular plane, the plane of the orbit there. Right? So there are doubts now. Yogendra is asking a question. What does it mean from geostationary orbit fall in the same category of geosynchronous orbit? It means here that they are those orbit which lies on the equatorial plane. That's what called fall under the geosynchronous orbit. Where the geostationary orbit comes? Equatorial plane. So when we say that geostationary come under the geosynchronous orbit, basically we are talking about the equatorial plane. You can say that geostationary orbit is a special type of geosynchronous orbit lying on an equatorial plane with a distance of 35,784 km, circular in nature, where satellite goes from west to east direction in a time period of 24 hours. So you can say that geostationary aspect is a special case of geosynchronous. योगेंद्र, जब जागो तभी सवेरा. Already break time is over. I am here now. That means you have joined the class late, or you are somewhere else, some other classes you are watching and then coming back to here. Whatever may be the case, or maybe from your job you may be working somewhere and now you have come back to the classes and you may be reviewing the earlier video. It might be a different situation there. But since you have asked the question, geosynchronous is a orbit which lies in an equatorial plane. But that orbit can be low Earth orbit, medium Earth orbit, high Earth orbit. Satellite can go with any kind of velocity speed there. It can take any number of time period of revolution. Now imagine that there is a geosynchronous orbit with respect to Earth rotation. What is geosynchronous? Geosynchronous means the satellite goes around the Earth with respect to Earth's rotation. What is geosynchronous? Where the satellite goes in the orbit with respect to Earth's rotation. That is called geosynchronous. Now imagine that there is a type of geosynchronous orbit where the satellite goes around the Earth with respect to Earth's rotation, west to east direction. Same time period of the Earth, circular orbit, located 36,000 approximate kilometer from the earth, where the relative position of the satellite from a ground point remains fixed. So that will call as a geostationary. So you can say geostationary is a special case of geosynchronous. Now Tushar Goyal, right? He is asking again what is stable and unstable point. I'll explain here. If you place any object here, satellite, right, and let's say it get displaced left or right, what happens here? If you place anything, there is a force of gravity because of sun, and there is a force of gravity because of earth. Now let's say L1 point, you place satellite and the satellite is here, and let's say this satellite get displaced, let's say it get displaced to here. What will be resultant force? There will be higher resultant force from the sun than the earth. So this satellite will not be able to get back, will not be able to spring back, get back to the L1 point. Why the satellite will not be able to come back to L1 point? Because now it will have the forces of gravity of the sun and the earth in such a manner that it will not bring it back. That is called unstable equilibrium. Same way here, if you have a satellite here, right, you have net forces acting from earth and the sun, and let's say the satellite get displaced further. So the net force which is acting on the L2 will change. There will be change in the force, and when the change of the force is there, it will not return back to the point. That is what called unstable. If you remember that, go back to your basic science class, your physics class, equilibrium. If you have gone to class 9th standard and you would have read about equilibrium. What is there is something called Bobo doll kind of a, what is the, like for example, you have a doll which is heavier at the base, and if you give a jerk here, it remains like here, right? But let's say you give a force here and it is come back. This is called stable equilibrium. It comes back. If you give a force here, it comes back. It is stable. But if it doesn't come back, it is unstable. Right? So here what happens, center of gravity that plays there. But if you talk about here, if you take a satellite is here L4, so you have a force because of the sun and you have force because of the earth. So you have resultant force which makes it to remain as a part of it. So if it get displaced, let's say if it goes here, again the resultant force by the sun and the earth will be such a way that it will displace it back to the L4. Or if it gets here, again the resultant force of the sun and the earth will be such a way, the net force, it will spring it back to the L4 point. So this is what called stable. It becomes stable equilibrium. It will come back to the L4 point. But what will happen here, if it displaces, it will not be able to return back to the L1 or L2 point. So here it is a unstable. This is a unstable equilibrium. It will not return back. That is unstable. Because the resultant force will change. But L4 and L5, like an equilateral triangle, is a net just like a 60 degree, 60 degree, 60 degree. The resultant force, even if it moves, the resultant force will be again which will bring it back to the L4 point or L5 point. That is what L4 and L5 are, stable equilibrium. Right? It all happens through the vector algebra and mathematics part of it. Did you understand this halo orbit? Consider halo orbit here. Now what I would like to bring here, for Earth and the Sun system, for Earth, Sun system, right? For Earth and Sun system, any kind of space exploration, uses L1 point for study of sun. For study of sun and sun's corona and all those part, L1 is the preferred one. Why L1 is preferred? because L1 is between sun and the earth, right? So L1 point will be preferred one for study of sun, right? Whereas L2 point, right, for study of deep universe. The other part of the universe, the deep universe, we can prefer the L2 point. Where is the L2 point? L2 point is in the back side. This is the L2 is the back side, behind the earth. That is L2 point. L3, we don't use L3 point. L3 point is not used. Why L3 point is not used? Is not used because it is far, far away. As it is very far away from the earth. So the signal which will come from that point will be very, it will take a long time. Where is L3? L3 is here, back side of the sun. And let's say you place a satellite here, the satellite has to communicate with the earth. The satellite, if you place L3 point, the satellite has to communicate with the earth. So it will be very, very far away. It will take a long time for signal to come back to the earth. So the preferred one is L1, L2. But you will say that, sir, you told that L1, L2, L3 are unstable and L4 or L5 are stable. Why don't we use L4, L5? That will be much better. You can argue there, you can give this argument that L2 and L1 are also unstable point. So why to go for unstable equilibrium? Why not it better we use L4 and L5? Because if you place L4 here, L4 point, L4 will also get the data of the sun and get the signal back to the earth, relay the signal back to the earth. Or L5 also can watch sun and can relay it back to the earth. So why not to use L4, L5 points? You can put that argument and they will be relatively stable as compared to L1. The point is that L4 and L5, if we talk L4 and L5 point, L4 and L5 points are not used, right? They are not used because of the presence of, there are some presence of, right, near earth asteroid. There is a presence of near earth asteroid or meteorites there. Presence of near earth asteroids and meteorites which can affect space missions. Why a space agency doesn't prefer to use L4 and L5 points for sun and the earth system? Because such L4 point and L5 point, there is a meteorite present. Natural meteorites are there. Or sometimes the asteroid, where the asteroid belt is there. Asteroid belt lies between Mars and Jupiter. But there are certain asteroid, rocky type asteroid, which come near to the earth, called as a near earth asteroid. And they find the place in the L4 points and such kind of points there, right? That's what the space agencies will not prefer the L4, L5, although they are stable point, because of the presence of such kind of near earth asteroids and meteoroids on L4 and L5 points. Mr. Pratik is asking a question. The point is Lagrangian points are points where forces are zero. Then how they will displace it? Forces are not zero. Forces get balanced. Net force becomes zero. They are opposing forces. There is nothing called force equal to zero. There is no force zero. There is no zero forces. The opposing forces, they counterbalance each other. I know that there are some kind of very over smart student in the classroom. I understand that, right? They will try to, catch something and then try to, do the part of it. I know that. Every batch has some such kind of student. Mr. Pratik, There is nothing called zero force. There is no zero force in the alpha L5. There, what I said in the beginning? What I said in the beginning? I said there are two types of forces. One is the force of gravity, and second, because of the motion, there will be also centripetal force. So the counter forces, they balance each other. Resultant force, that becomes zero, right? Resultant force, that becomes zero. It doesn't mean that there is no force. It doesn't mean that there is no force. There is forces. There are forces of gravity because of the sun and the earth. At the same time, centripetal forces which happens because of the motion of the around the sun, because of that particular point there. The balancing forces are there. Now, based on the Pratik question, what Pratik has asked the question, based on that, now what I would like to bring here, if we are going to use a L1 point or L2 point, we have to control the satellite from the ground station. What we have to do? We have to continuously control the satellite on L1 and L2. It requires control from the ground. Today, satellite technology, today the spacecraft technology has advanced to a stage where its every aspect can be controlled and commanded from the ground station. And we will always require what? Course correction. Where we have to require course correction? L1 and L2 point, L3 point. It's not that you will put something there, काम हो गया, ऐसा नहीं होता है. That you have taken a satellite, placed on L1, हो गया, and the signal will keep on coming. No, it's not like that. It's a very complex, it's a very, very complex aspect. Once you place into that kind of a halo orbit, again you need to control the satellite motion, the movement, your command and control from the ground station to keep on the track, because the forces will always keep on changing the position there. So what is required here? L1, L2 point here. So remember that, what point I am writing here, that L1, L2 points require continuous, there has to be continuous course correction there, continuous control in motion of spacecraft on these points from ground station. And why we are not using L4, L5 point? Because of the presence of such celestial bodies like near the asteroid and the meteoroids there. That's what L4, L5 are not used. L1, L2 point require continuous control in motion of the spacecraft or satellite which is placed there on these points from the ground station. You need correction there. It's not a very easy task, right? Now, there is a question by Tarun. Satellite will also be revolving around the earth, so how will it maintain its position at L1, L2? It doesn't it will not go around the earth. What is asking that? If you place here, so this will go around the earth and again go around the sun. No, it's not like that. It's not like that. The satellite you place here, it will go like this earth and then again go like sun. No, it's not like that. What I said, it is like this one. This is called halo orbit. What I gave the concept here, halo orbit, 3-dimensional space. I mentioned very clearly halo orbit. I know there may be students in your batch who have overread. There are some people who read a lot of current affairs. This website, that material, and all, here junk. Without having clear understanding, all the things are there. So all those students who are like that, you have to change your habit, change your way of reading. UPSC questions are very simple also, and it check clear crystal understanding. What I said here, halo orbit. What is halo orbit here? Is basically a 3-dimensional space where the satellite goes like this. It will not revolve around the earth. The forces act in such a way that that particular L1 point or L2 point, it creates a kind of a three-dimensional space where the satellite moves. If this camera is the sun and I am the earth, you imagine that this is the L1 point where I am keeping the marker. So satellite goes like this, and together with the earth it will move around, right? Together with the earth it will also move around there. Satellite will keep on moving like this one. Together with the earth it will move around. It's not that it will go around the earth and then go around the sun, right? That's where the concept of L1, L2, L3 points comes. All right, to clear, go and watch videos, not which videos of teachers and those kind of now videos what has happened on YouTube and all this your Telegram group and all those kind of you are hooked to it, and what happens in that kind of you watch videos of the teachers and coaching institute and then hundreds of such kind of thing there. If you have to really watch this important from UPSC point of view, then please watch documentaries which can give you the understanding there. YouTube have got number of good documentaries here. You go and watch those kind of scientific documentary which gives you a really good understanding there, right? Rather than coming to such kind of you can see here this is, or visit some kind of website which will give you the real insight of the cosmological thing there. It will come to your it has not come to your screen. Let me see here. What I want to say here that if you have to really watch some kind of important scientific kind of documentary rather than those kind of nowadays new type of teachers have come up teaching science take and all these areas, right? They will teach you the same thing what is there in the all kind of junk materials around in the market. It is not going to help you out. If you want to really solve UPSC question, get a good understanding, is always if you want to use some kind of videos and all this one. If you do the Google search and you go to YouTube, you will find such beautiful animation, good kind of knowledge oriented kind of a documentaries which will really help you out, right? Now if you see here, I will now get to this Lagrange point here. Now see here. I hope that screen has come. It has not come. Any more doubt you have about Lagrange points? बोलो वहां से फिट नहीं दे रहे हैं. What I have seen in your chat box is that you are having a lot of personal conversation. Chat box has been given to utilize for a better in terms of learning process. Right? The teacher is able to read the chat box. It's not that the chat box, whatever you type, whatever you write, that is not visible to the teacher. Teacher sees everything there, right? So whenever you have to, then you have to make best use of the platform provided by Vision IS in terms of learning process and all this, right? So I know that there are sincere students, there are good students in the batch who really make best use of the such kind of resources, right? To make use of that kind of system there, right? So whenever you have any such kind of doubt, you just visit some of the website which discuss about Lagrange points or Lagrangian points, or you try to go to some kind of animation which makes you, whatever the points I have already given here. If these points are clear, then it won't be a problem for you there, right? Now India is going to have Aditya L1 mission. Now what is important for UPSC exam? Aditya L1 mission, Lagrange point 1. There we are going to use Aditya mission. That is going to be first mission of India to study the sun and the outer corona of the sun, chronosphere of the sun. That is India's mission for that. Earlier it was planned for 2021-22, but because of the COVID-19 pandemic, it has been now postponed, right? Presently at L1 point, NASA and European Space Agency ESA is having an observatory for study of the sun called SOHO, right? Let me write that point also. Presently at this point, L1 point here, Solar Heliospheric Observatory, that is jointly by NASA and ESA, that is being used for study of sun. Whatever the document or data we get on the sun, that is because of the SOHO, L1 point. And India is also planning for, in future, India is planning here, ISRO is planning for Aditya mission there, Aditya L1 mission for study of sun and outer corona of the sun. I'll give you more detail of the Aditya mission, but I'm just bringing the point here, right? Now L1 point, when you talk about L1 point, L1 and L2 point here, for sun and the earth system. For the sun and the earth system, L1 equal to L2 is equal to 1.5 million kilometers. That is around 15 lakh kilometers from earth. How many lakh kilometers from earth? It is 15 lakh kilometers or 1.5 million kilometers. $1.5 million kilometers is the distance of L1 point or L2 point from earth, and that is equivalent to 15 lakh kilometer. If you take moon is 3,84,000 kilometer away from the earth. Moon is 3,84,000 kilometer away from the earth, right? Whereas the L1 point is even farther than the moon. It is located at 1.5 million kilometers or 15 lakh kilometers from the earth's surface, even farther than the moon, right? In geography you have studied, moon is approximately 3,84,000 kilometers away from the earth. So L1 and L2 point is beyond those points there. So if you place a spacecraft or a satellite on L1 point between earth and the sun there will be no effect of the eclipse. When the eclipse happens, when moon comes between sun and the earth, you have a solar eclipse, right? So those kind of effect will not be on the satellite, because the satellite is placed at 15 lakh kilometers, that is beyond the moon, right? So if you see here, in context of this points here, so that I have already explained here. I have said that all those kind of satellite which is placed there, they are all again controlled and commanded from the earth station. Yes, if we don't control, it will fall to the sun, it will go near to the sun. It will not get into the sun, but again revolve around the sun just like a planet. Right? Just like a planet, it will go around the sun. if it goes outside the sphere of influence of this Earth's gravity's influence, it will go around the sun as any heavenly body will go around the sun in an orbit. So if there is no control and command there, then what will happen in this case? In that context, the satellite will not fall into the sun. The satellite will just go and move around the part of the sun just like any other celestial body does. Clear? As any other celestial body comes there. All right. Okay, Arjit is asking a question there. With respect to halo orbit, can it be said that it's the space that moves irrespective of the perigee or apogee? It's a distance with respect to both Earth and the sun, with the movement also change there. Yes, that is almost like that. Not completely, but almost is like that one only. Right? It's almost like that one. So now let's look at halo orbit. Is almost like this one. Now see here, this is the all of you have written this one, whatever written on the whiteboard. एक सेकंड रुक जाइए. Has all students written what is given on the whiteboard? Have you all copied down whatever the points are there on the whiteboard? Yes or no? Have you written the points on the whiteboard? Okay, it is written. So I am coming to Arjit's point here. Halo point there. अब मिटा दीजिए वहाँ पर. So halo point, if you see here, is a three-dimensional orbit near one of the L1, L2 or L3 Lagrange point in the three-body problem of orbital mechanics. That is what is given there. Although Lagrange point is just a point in empty space, its peculiar characteristic is that it can be orbited by a Lissajous orbit or a halo orbit. And this kind of halo orbit, if you see here, they just like angle it goes into that. I'll just give you the animation. If you see the animation, you'll be able to see that. अब आ जाएगा इसका स्क्रीन पे? हाँ? आ रहा है या नहीं आ रहा है? Now see here, this is the halo orbit.
Planning to build a station for astronauts orbiting the moon, a project known as the Lunar Orbital Platform Gateway. According to an ESA press release, the Gateway space station will follow a near rectilinear halo orbit, or NRHO. Gateway will pass 3,000 kilometers from the lunar surface at its closest and 70,000 kilometers at its furthest. One revolution around the moon takes approximately 7 days. The ESA reports that a halo orbit is possible due to the gravitational interplay between the Earth and the Moon, which creates a small area of stability or near stability known as libration or Lagrange points. But as NRHO isn't entirely stable, the gateway will require periodic maneuvering to keep it from drifting off course. The space station is slated for completion in the mid-2020s. According to Space.com, NASA's 2019 fiscal budget request calls for a 2022 launch of the power and propulsion module. 2 additional launches by 2025 will add habitation, logistics, and airlock functions. According to the ESA, Gateway will serve as a staging post where astronauts can dock and leave their spacecraft, then travel to the lunar surface in a lander. It will also provide them shelter, a place to stock up on fuel and supplies and relay communications, and a base to dispatch crew and robots to the moon.
What you have just seen here is that there is a halo orbit there where you have this part of the motion of the satellite in a orbit, three-dimensional orbit with respect to the Earth, right? That is how it works there. And anyway, since the network is not and you are not able to get the feed there, so I won't be able to place that Lagrange points there, but anyway, let me see here if I can make you audible there, because then I'll just take you to the Aditya mission of the ISRO.
NASA is planning to build a station for astronauts orbiting the Moon, a project known as the Lunar Orbital Platform Gateway. According to an ESA press release, the Gateway space station will follow a near rectilinear halo orbit, or NRHO. Gateway will pass 3,000 kilometers from the lunar surface at its closest and 70,000 kilometers at its furthest. One revolution around the Moon takes approximately 7 days. The ESA reports that a halo orbit is possible due to the gravitational interplay between the Earth and the Moon, which creates a small area of stability or near stability known as libration or Lagrange points. But as NRHO isn't entirely stable, the Gateway will require periodic maneuvering to keep it from drifting off course. The space station is slated for completion in the mid-2020s. According to Space.com, NASA's 2019 fiscal budget request calls for a 2022 launch of the Power and Propulsion Module. 2 additional launches by 2025 will add habitation, logistics, and airlock functions. According to the ESA, Gateway will serve as a staging post where astronauts can dock and leave their spacecraft, then travel to the lunar surface in a lander. It will also provide them shelter, a place to stock up on fuel and supplies and relay communications, and a base to dispatch crew and robots to the Moon.
See now, since the video feed is not coming, right? The video feed is not coming and the audio feed is not coming. All right. So what will be done? This video will be, when the recorded video, when you get the recorded video, it will be added by the team here. All right. I know that I've seen in the chat box that it is not visible to you because direct camera is taking from the projector, so you are not able to see the video there, right? At the same time, the sound, because the mic, I just kept right now the mics to, but it is not very clear there. So what the video team will do, they will edit the recorded video and then put the video. You will be able to see that. All right. So anyway, I have explained that the halo orbit is basically with respect to the Earth, this three-dimensional part. What Arijit is saying that, its space, the moves irrespective of the perigee or apogee, it goes in that case. The distance with respect to both Earth and the Sun, with the movement also changes there, right? That's what you, Arijit, what you are saying is correct there, right? Now what I would like to bring here, the Aditya mission of ISRO. Aditya mission of the ISRO, if you look at, if you say, if you go to the ISRO website here, Aditya L1 mission of ISRO, you get all the payload also there, right? You'll get to know the what exactly the mission is all about there. Now this is the web page there, right? See, Aditya L1, the first Indian mission to study the sun. Now what was earlier planned? Earlier planned was 400 kilogram class satellite, which will carry the into 800 kilometer low Earth orbit. But then the ISRO came to the part that we will use L1 point. This is the initial project concept. Initially ISRO thought of placing a 400 kilogram satellite into low Earth orbit, 800 kilometer, but now the mission has been revised and we are going to use the L1 point. A satellite placed in the halo orbit around the Lagrangian point L1 of the Sun Earth system has the major advantage of continuously seeing the sun without any kind of eclipse, right? And this is what the 15 lakh kilometers away from the Earth, this mission will be accomplished in future. And it is a very important topic for the examination. UPSC can ask you question on that, but now it has been, right, had been extended. Now what the Aditya mission will do, Aditya mission will study the sun's corona. What will be here? It will study the solar corona. Corona is the outer part of the sun, and there is one very important aspect of the corona is that corona extends thousands of kilometers even outside the sun, the extent of the corona. And the temperature of the corona is millions of degrees centigrade, is very, very high as compared to photosphere, the inner disk of the sun. it has 6000 Kelvin, whereas the outer part of the corona that heats up to millions of degree Kelvin. So the scientists will try to understand why there is a temperature difference between outer corona and the inner disk. Did you understand? Inner disk has 6000 Kelvin, whereas the outside the temperature goes to millions of degrees centigrade. So first objective is that it has temperature of more than million degree Kelvin, where the outer part of the corona, whereas the inside part, the solar disk temperature is just around 6000 Kelvin. So the first objective of Aditya mission will be to understand why such a huge temperature difference between outer corona and the inner disk is there. Right? Just understand, just I'll give you understanding here. If you are standing near a hot object, the temperature will be higher, you will feel more hot, right? As you go away from the hot object, temperature will be lower and you will feel cooler there. Now what is the source of energy for sun? The source of energy for sun is the nuclear fusion, FUSION, nuclear fusion reaction, where hydrogen and hydrogen fuse together to form helium, thermonuclear reaction, right? So now imagine sun is the star, sun is our star, and sun as a star has a core, and the core of the sun is like a nuclear furnace, where hydrogen and hydrogen combine to form helium and enormous energy is there. So let's say if this is the core, of the sun, the central part of the sun, what I have just told is the core of the sun, so definitely temperature around the core will be higher. As you move away from the core, the radiant energy will decrease, temperature will be lower. Where is sun's corona? Sun's corona is the outermost part. The corona of the sun is the outermost part, right? Away from the core of the sun. So by this logic, radiant energy and temperature of the corona must be lower. Are you able to understand? Whereas the inner part, inside the corona, which is nearer to the core, this is the core of the sun, nearer to the core, the inside part of it should have higher temperature, whereas the outside part, the corona, temperature should be lower. What we find in the case of sun? It is just the opposite. It's just the opposite. That outer corona, the temperature goes to millions of degree Kelvin, whereas the inner part is just 6000 Kelvin. So this is a mystery about the sun. So Aditya will try to understand what factor is responsible for very high temperature of the corona. Now second thing is that it will also carry the experiment on the sun's corona, soft X-ray, hard X-ray, then emission line, visible and near infrared, chromosphere, photosphere, all will study. Now what is very important part of here is that sun, right, sun in a time period of 11 to 12 years emit very powerful waves, very strong electromagnetic waves, and particles are released from corona of the sun. It is called as coronal mass ejection. What is called that? Coronal mass ejection, CME, which is also called solar tsunami, solar flares. What do you come across in newspaper when you read newspaper and current affairs? Solar flares, FLARES, solar storm, solar tsunami, right? So this solar flares, the technical word for the solar flares is coronal mass ejection, CME. So the time period of 11 to 12 years, the outer corona of the sun eject powerful waves and particles which have influence on space weather, and such powerful waves and particles reach up to the earth and affect the earth's atmosphere, right, where the ionosphere get affected, right, our communication system get affected because of the coronal mass ejection, because of the coronal solar storm or tsunami or flares. So Aditya will also try to understand the origin of solar storm, solar flares, or coronal mass ejection. It will study the sunspot and the plasma, the ionized state of the sun, and try to understand the cause of the flares to be emitted, powerful wave and particles to be emitted from the sun's corona. These are the objectives of Aditya mission. So here you will find here on the ISRO side, these are the 7 instruments which will be on board Aditya spacecraft, and visible emission line chronograph, then solar ultraviolet imaging telescope, then the Aditya solar wind particle experiment, plasma analyzer package for Aditya, solar low energy X-ray spectrometer, high energy L1 orbiting X-ray spectrometer, and there will be magnetometer, right. Is it clear here? I have explained what is basically the Aditya mission there. The video will be put into the recorded one. If you do the simple Lagrange point, you will be able to see that. If you just do the Lagrangian points, I'll just show you that. The video what you are talking about, this is a video here. If we do the halo orbit, this is the one. Halo orbit chosen for Gateway Space Station of European Space Agency, you will find that. In the YouTube you have News Direct. And what I was trying to play, and it was not been there, this is the another one. Universetoday.com. What are the Lagrange points? Universetoday.com, where you have a Lagrange point there. And then I was trying to show you this another one which didn't work well. That was this one. If you just go to this, you can also yourself can go to the such kind of videos there. This is the one. This one. This video will be added to your recorded video. When you do the Lagrangian points search, this video will come. This video basically explain you what are the Lagrangian points, right? But this will be part of your recorded video. The team will put into the recorded video, so don't worry about that. All right. So anyway, I will end the class here, and I'll give you the assignment question here. Tomorrow we'll start launch vehicle technology, right? Today I'm not going to start there because already time is up. But tomorrow I'll be going to the launch vehicle technology. So your assignment question is this one. Discuss Aditya L1 mission. What I just explained in the classroom, you can go to ISRO site and write this answer there. L1 mission of ISRO, right? The question is that of today's assignment question, discuss Aditya L1 mission of ISRO. You have to write in 150 words. Like here, you have to give you have to sketch everything of the Aditya mission. You have to write everything about Aditya mission. Go and visit the ISRO site, read about Aditya mission, and write in your own words with the name of the instruments and everything. And please make this kind of question answer also written in the note copy. I am giving you the note copy in terms of class notes by writing on the whiteboard, which you are copying on your note copy. So please, whatever I am teaching and giving on the whiteboard the points, do write that. And there you try to also answer this question of Aditya L1 mission, discuss the Aditya L1 mission of ISRO. That will be a kind of a class notes for you. The answer of the Aditya L1 mission, which you will read and write, will serve as a kind of class notes for you. That I am giving as a homework assignment. All right. Tomorrow will be an important class. Tomorrow I am going to discuss 3 topics. First, launch vehicles. We'll discuss about RLV, PSLV, GSLV and all this area. Second will be on satellites, different types of satellites and their application. And third, we will discuss about ISRO. With ISRO, we will study about INSAT, GSAT, IRS system, and all those areas will come into that. All right. So that will be the tomorrow's topic of the class. So I hope that you will follow that one, right? So thank you everyone. We'll meet in tomorrow's class. Thank you. Thanks a lot.